Hi friends, today this is really exciting because we get to start our two-column proofs, which is a huge part of geometry, and I love sharing this with you because it's a really great way to understand a little bit more about math. So this video in particular is talking about justifying your steps when you're doing a two-column proof. And so we're going to start by showing you what our two-column proof is going to look like. We have this example here. Given that 3 minus x over 6 equals 5, I want you to prove that x equals negative 12. Well, we're going to be making some statements over here on the left, and then on the second column, our reasons are going to be on, we're going to use our reasons on this column. Now, remember, our reasons can be things like properties. So we've been introduced to some properties before this, like addition, subtraction, multiplication, division, if you do it on either side. Vertical angles are congruent, supplementary angles are 180, complementary are 90. Again, pause if you don't have these written down, make sure that you do. And then the most recent one we have learned about are the reflexive, symmetric, and transitive property. Now, if it helps, the reflexive property it's like things like 3 equals 3 and x equals x. I call that the duh property. Duh, of course, x equals x, it's x. The symmetric property is a mirror. So you can see that if you held up a mirror, it would reflect across either side. That's why it's kind of tricky because you don't want to get it confused with reflexive. So this is our mirror property. The transitive property, I call this guy the middleman property. And the reason being is if x equals y and y equals a, then x equals a. All we're doing is just lobbing off that middleman there and going straight to the source and saying x equals a. Okay, so now let's use those reasons, those properties, as our reasons in our two-column proof. So the very first thing we want to do in this proof is we want to minus 3 from both sides. If we do that, we are given negative x over 6 equals 2. Now, for the step that allowed me to do that there was the subtraction property of equality. Subtraction property of equality. I'm going to go ahead and abbreviate while we're doing this. Okay, so then I want to get this x by itself, right? And I'm dividing by 6, and the opposite of divide is to multiply. So I'm going to multiply both sides by 6 because that will get rid of it. So for 3, I'm left with negative x equals 12. And the reason I was allowed to do that is the multiplication property. Multiplication property of equality. Multiplication. Oh my gosh, that was way too much. I don't know. I interrupted myself. So sorry about that. The multiplication property of equality allowed us to do that. Now for our fourth step here, our x is still not by itself. We want to divide both sides by negative 1. That will cancel out and we will end up with x equals negative 12. The property that allows us to divide on both sides is just the division property of equality. This time I didn't interrupt myself. All right, so those are our two properties, or those are our two-column proofs. Now we have one more example that I'd like to do as well. So for this one, given all of this, prove this. All right, so given that negative 7 times quantity x plus 2 plus, close your parentheses, and then plus x, 4x equals 6 quantity 2x minus 4. Prove that x equals 2 over 3. The very first thing you do on any proof, just to make your life easier, is you write down what you're given. I mean, those are free points right there. Just write down what you're given and you get some points. All right, let's take a look at this. Now, from this point to our next one, the first thing that we're going to need to do to solve this is distribute that negative 7 and that 6. So we are going to get negative 7x minus 14, because negative times a positive is a negative, plus 4x equals 12x minus 24. And what allowed me to do that was the distributive property. Distributive property. Okay. So the next part that we would want to do is combine some like terms. Like I see a negative 7 and a positive 4x here. So that would be negative 3x minus 14 equals 12x minus 24. Now, I'm okay with simplified. Double check with your teacher. So simplify. Sometimes some teachers call it the substitution property because we're actually substituting that in for this. But I think simplify works best. So for number 4, first we got to do something. I always, when we have variables on both sides of our equation, deal with your variables first, because if you don't, you run the risk of making a mistake when you're, if x happens to equal 0. So we're going to minus 12x from both sides. All right, that gives us negative 15x. So this is number 4. Negative 15x minus 14 equals negative 24. And what, oh, I forgot my x. There we go. And what allowed us to get to this step is that we subtracted 12x from both sides. So that is the subtraction property of equality. All right, so from this point, what we want to do is add 14 to both sides. Add 14. If we do that, we are left with negative 15x equals negative 10. And that, if we're adding to both sides, is the addition property of equality. Addition property of equality allows us to add to both sides. Okay, now to get that x by itself, we're going to divide by negative 15, negative 15. So for number 6, we get x equals negative 10 over 15. Negative divided by negative is a positive, so we're going to say 10 over 15. And what allowed us to do that was the division property. Now, of course, you are not done, because remember, you can simplify this. So for number 7, we're going to say x equals, and if we divide both the top and bottom by 5, we end up with 2 over 3. So that guy would be for simplify. Simplify. And there you have just done another 2-column proof with algebra using your reasons that you have learned about, your properties, in your reasons column. So good luck, and we look forward to seeing you next time.